Hello everyone, my name is Madeline and today Vamika and I will be presenting a fun jewelry box that we designed and built using SolidWorks and 3D printing. Jewelry boxes are often mass-produced and may lack personalization, and so we wanted to create a customizable jewelry box that integrates a personalized and playful experience as well as structural stability and mechanical motion. Using gears and a Lego figure will make the jewelry box interactive and fun. To begin, here is our ideation sketch. Our idea was to create a small jewelry box that has a sliding drawer, gears, and a Lego figure on top to give it a fun and playful experience. Moving on to the parts created, here is a drawer that I created, and it's a sliding drawer that easily comes in and out of the box, and jewelry and small items are stored inside, and it includes a handle to easily grip the drawer and make it easy to pull out. And now here is the drawing file that shows the dimensions. Now here is the main box that I also created, and so this is the outer structure of the jewelry box, and as you can see, fillets were used to smooth the sharp edges, and it also provides support and stability for the other components. And inside, it's sized to fit the drawer and hold the items stored inside. And here you can see the dimensions.
In our design, we incorporated two spur gears. This gear on the right is our driving gear and it is made up of 10 teeth. This gear on the left is made up of 20 teeth. So we have a 1:2 ratio going on, which means that we are prioritizing torque over speed for making the Lego figurine move. So here's how these two gears would interlock and work together in real life. And now let's move on to the drawing files. So taking a look at the drawing files, we have the thickness of these gears to be 10 millimeters, and these holes over here are where the axles are going to go through. So the hole on the driving gear is 5 millimeters, and the diameter for this gear is 9 millimeters. Here is the axle that goes into the larger gear. And so over here, this thing at the top, this is where the Lego piece fits inside of. So now moving on to its drawing file, let's take a look at it. So here is the axle's drawing file, and so we can see that it has a height of 42 millimeters in total, and these are the diameters of the main outer part of the cylinder and then the smaller part that will go inside of the Lego piece. Here we have the axle for the small gear, which also acts as the handle. So this top portion over here, this larger cylinder, is the axle, and then over here, the cylinder with the smaller diameter acts as the place where the gear would attach to. So now let's take a look at the drawing file. So now here we have the drawing file. There's only 3 views because the right side view isn't necessary, as we can see all of the dimensions right from here. So the total height is 65 millimeters, and then we have the larger part where we can hold on to being a diameter of 10 millimeters, and the smaller one where the gear would go through be 4.25 millimeters. Finally, we have the table. It has these 4 legs over here, which allows it to stand on top of the jewelry box. These 2 holes over here are where the axles are going to go through, and then the gears and as well as the Lego piece. Let's take a look at the drawing file for this piece. So here we have it. Here's the isometric, top view, front view, and the right view.
So over here we have the jewelry box. At the bottom we have the drawer. Now this drawer can be taken out and removed, and jewelry like this can be placed inside and then can be safely stored back over here. Moving up, we have the spur gears over here and the handle. Now, when this handle is turned, it'll cause the figure to turn due to these gears over here. So if I spin it, it'll move like this. And then just to make sure that everything's a tight fit, this Lego piece won't fall out, even if I turn it upside down. Thank you.
Biggest challenge we ran into would be accounting for tolerances. For instance, making sure that the axles would fit inside of the holes of the table and that the top part of the axle would fit into the Lego piece took a few prototypes before they fit the way we wanted them to. However, we were able to ultimately combine all of these parts into our build, which we are super proud of. In the end, we were able to plan, design, 3D print, and assemble our jewelry box. Besides adding a drawer for where items like earrings and necklaces could be placed, we made the jewelry box more appealing by adding a Lego figurine that could be spun around using a handle. Through this project, not only were we able to improve our skills on SolidWorks and get to watch as our on-screen designs became tangible, but we had a lot of fun doing it. Thank you for watching, and I hope you enjoyed our project.